Good evening, be enthusiasts. Welcome, minions. Today, in this one short session, we are going to talk about how gas molecules behave, how the heat transfer process involves some kind of calculations, what are the calculations involved, and you will understand the different aspects of the behavior of molecules of a gas in kinetic theory of gases. Also, we're going to talk about phase conversions. Like you can see over here, this is a sublimation process, and obviously the heat involved in the phase transformation process. Like you can see on the screen, this is melting of ice, and we are going to solve some problems as well where there will be steam and ice both involved together, and that's going to be really interesting. So let's begin Calorimeter and Kinetic Theory of Gases with me, Shreyas, your master teacher for physics at Vedantu, going live. Hello everyone, how is everyone? Let me know how is the Josh. Hello Kirito, VK, Dhanush, Uncharted, Yalini. Just 1 second, guys. Let me just turn the light. Okay. Yes, welcome. Hello Bhavni, hello Yalini, Ankit, Aishwarya, Dhanush. Welcome Jagdish. Hello everyone. Let's begin with today's awesome session with me, Shreyas, your master teacher. And guys, those of you who are very new for this channel, so first of all, please say hi, hello to your friends out here, make new friends, and make sure that you are interactive with all the other minions out here. And let me just quickly introduce myself. Like you can see out here, so for the past 11 years, I have been teaching, and I have been involved in many different kinds of activities. Sometime back, I was in fact working for a multinational company. Then I switched over my job and entered teaching. I've done my graduation from NIT Nagpur in mechanical engineering, and my all India rank when I wrote my JEE was 3900. And when I started teaching, many of my students in fact cracked the JEE examination, not with any ordinary ranks, but also 2-digit all India ranks. And many of them are right now in IITs, NITs, BITS, you name it. And I really hope that I'll bring in that change within you. And that's why we have come up with this channel. Hello Sanjay, hello everyone, hello. Yes, so Bhavani, we have already come up with 30-day strategy, so please don't spam. Please check out our past videos for the 30-day strategy. In fact, I conducted one session yesterday, so please go ahead and check it out. Yes, Uncharted, I will continue with 11 sessions also. Like I promised, I'm going to complete waves, I'm going to complete thermodynamics, I'm going to complete sound. Do not worry about it. These chapters are going to be completed in the next 1 or 2 weeks. Do not worry about it. Okay. Hello, Naga Ramesh Babu Edara. Welcome. Hello, Rameni. Welcome. Okay. And guys, by the way, you can also follow me on Instagram. I'm planning to go live this week on Instagram. This is my Instagram handle, Shreyas_Vedantu, where I keep posting different updates, videos, motivational sessions, etc. So guys, do follow me over there, because there is going to be a special session, especially for KVPY. I'm planning something for all of you, last minute, something like tips or strategies. I'll let you know the date, time, etc. very soon. So do check me out over there as well. All right. And so light wave is a part of 12th standard, Dhanush, usually. Okay, and I hope guys, all the new members have already subscribed to our channel. That's how you become a member of this channel. Remember that. And the membership is free. And if you have not yet liked our video, please go ahead, like it, because all your love, your support and your likes are required for our energy, for our enthusiasm to conduct more sessions like this. So please go ahead and do that. It's free of cost. Hello Gandham Ramesh, welcome. And yes, do share it across as well. Yes, if you have your own social media account, please share our channel name, description, etc. with your friends, so that they can also attend our lectures. So we are right now over here, thermal physics, calorimeter and KTG. Yesterday I conducted a special session for strategy for last few weeks for cracking JEE Mains. And also, we have done complete 11th revision on Monday. A similar session is coming up on Saturday. Friday, you're going to have a marathon one-shot session on lenses and prisms, that is optics. And tomorrow, it's going to be a paper discussion, very important session, guys. The first paper of last year, The first day, first slot paper will be discussed over here, just like you had a discussion with Wasim sir today. So you're going to have a paper discussion tomorrow. Okay, so let's begin. I hope you guys are ready now. Yes. Let's begin. Yes, everybody give a thumbs up if you guys are ready, if your Josh is high, and if you are all up to date, up to speed. Make sure your notebook is out. Keep making notes as well simultaneously and solve the problems as I solve on the board. All right, ready? Oh, very good. So Gandham, previous year questions, yes. If you are targeting 100 plus score, yes, more than enough. But if you are targeting 200 plus, you need to do more. Okay, Gandham? Now, specific heat capacity. So guys, if you take any object and if you heat it, the amount of heat you supply is going to change the temperature. And how much does the temperature change? Depends not only on how much mass is present, but also on the type of the matter which is there. For example, if you have more water, then if you supply same heat, the temperature won't change much because there is a lot of water. Same way, if instead of water, if there is some other liquid or maybe some other solid, then it won't change the temperature by the same amount. So the heat which you supply changes the temperature, and the temperature change depends on the mass and the characteristic of the material, and the formula for that is given by this. And this is a formula. The heat which you supply is going to affect the change in temperature like this. This M is obviously the mass. This C is called as the specific heat capacity. Very important. This is called as the specific heat capacity, and it depends completely on the material. Remember that. Obviously, delta T is change in temperature, Q is the heat supplied. The unit for specific heat capacity can be easily seen. Q is in joules, mass goes below, so it is kg, and temperature is in Kelvin. So you can write it like this, or you can have other units as well, calories per gram per degree Celsius, and so on and so forth. So it's up to you how you want to write it. So different possible units are there. And to give an example, specific heat capacity of water is 1 calorie per gram per degree Celsius. So this is also another important formula which you should know. Standard, this is in fact how calorie is defined. So if you take 1 gram of water and if you heat it by 1 degree Celsius, then you would have supplied 1 calorie of heat. And obviously you should know the conversion, and that conversion is 1 calorie is approximately 4.2 joules of heat. So this is the conversion factor to convert from calories to joules. This is something which you should remember. Albert, you're not so late, but I think just 5 minutes maybe you can just recap, rewind and catch up. Okay, I hope this is clear. Q is mc delta T, C specific heat capacity. Specific heat capacity of water is 1 calorie per gram per degree centigrade, and 1 calorie is 4.2 joules. Now, there is another variation in this formula which you must know. See, Q is m small c delta T. Sometimes you can also write it as capital C delta T. What is the difference? This C is called as specific heat capacity. This capital C is just called as heat capacity. So heat capacity, capital C, is small m into small c. Specific heat capacity into mass gives you the total heat capacity of that solid, liquid or gas. Will the value of C be given to you? Yes, most of the times it will be given, or it will be like a variable, or you will have to find it out because other pieces of information will be given to you. Keep this in mind. Okay, I hope this is clear. Yes. So having said that, let's get going ahead. Now, next, let's talk about phase changes, liquid, gases and solids. So we just saw that if you have a liquid or a solid and if you supply some heat, the temperature increases. But understand, the temperature can increase only till a certain extent. For example, if you have water in liquid state, that is water is in liquid state, if you heat it, the temperature of water keeps rising only till 100 degrees Celsius under normal conditions. After 100, it will get converted into the vapor form or the gaseous state. So guys, understand that point till which, the temperature can change, you can use the previous formula. Q is mc delta T. But the moment the phase changes, the state of the matter changes, there is a different formula which you have to take into account. And for phase transformation, there is a very simple formula, and that's what I'm going to tell you about. So for phase change, for example, if you take ice and it melts, or if you have water and it boils. So for that, we have a formula which is Q is ml, where that L is latent heat, and that latent heat is nothing but the amount of heat required to change the state per gram of that object. So let's say if I take 1 gram of ice, and if I need some amount of heat to melt it, that amount of heat required per gram or per kg or per unit mass is called as the latent heat. I hope this is clear. I hope this is clear. This is very, very important. Finnegan, I'm not ignoring class 11th. In fact, I hope you realize, Finnegan, this is class 11th. I'm not sure which standard you are in. This is in fact class 11th. Okay. So this is not ignoring. So please concentrate on the class, guys, and please focus. And minions out there, come on. Please focus on the class. You guys are letting other intrions out here to disturb the class. So guys, please focus and make sure that the chat box is controlled. Yes, very important point, Uncharted. In fact, I'm coming to that. So latent heat. So latent heat is nothing but, let's say, if there is a mass m and I change the state from solid to liquid, liquid to gas, or gas to liquid, or liquid to solid, any phase transformation, that Q is given by m into L. This is latent heat of that particular transformation. Whatever that latent heat is for that particular transformation, that m is the mass. So this latent heat, understand, has the unit of joules per kg, or it has the unit of calories per gram. That is very important. And to give you some idea, latent heat for converting from ice to let's say water, or from water to ice, one and the same thing, because if you convert ice into water, you will have to supply some heat, but if you take away the same heat from water, then you will get back the same amount of heat, and that heat is known to be 80 calories per gram. This is some standard value you should remember. And latent heat to convert from water or back to steam or water vapor, it is 540 calories per grams, again standard value. So if you take 1 gram of water, if you want to convert it into steam, you need to supply 540 calories. Also, from 1 gram of steam, if you take away 540 calories, then it will convert back into water. Understand, this will be obviously at 0 degrees Celsius, and this will be obviously at 100 degrees Celsius. Please understand, the latent heat of transformation happens at a particular temperature. So understand, these processes are isothermal process. These are isothermal processes because the ice, when it converts into water, understand the temperature remains 0 degrees Celsius until the last bit of ice converts into water. Same way, when water boils at 100 degrees Celsius until the last bit of water converts into steam. And the reverse is also true. So when steam converts into water, the temperature remains or condenses into water, the temperature remains at 100 degrees Celsius. I hope this is clear. Okay, so if latent heat becomes 0, Ankit, that means it does not require any heat to change the state. So that is not possible. Obviously, you need some amount of heat to transform the phase. I hope this is clear. Cool. So let's get going. All right. Dinesh, I never forget minions, don't worry. And so Dinesh, so that's what you need to maintain the chat box. So, you should be the mascots, Dinesh, and you should be able to report if there is somebody who is unnecessarily causing any trouble and all that, so that you minions do not face the brunt or probably face the side effects of some spammer. Okay, Dinesh? Yes. Cool. Now, let's start solving problems based on this. And for all those of you who wanted to know the timetable of the new crash course batch, which is about to start from tomorrow, this is the physics schedule. Obviously, this is in English. I'm talking about the English batch. There is also a Hindi batch, which has roughly the same timetable, but slightly different dates and different timings, but not much change. So right from 11th standard till the 12th standard portion, from vectors to semiconductors, all topics will be covered in these sessions. These are the physics sessions. These are the chemistry sessions, again conducted in English by our JEE experts, right from atomic structure, GOC, organic chemistry, inorganic chemistry, metallurgy, polymers, everything covered before your second attempt, so that you are well prepared for your second, third and fourth attempt. Understand, this is very important. And this is maths schedule, again taught by our JEE experts, right from sequence series, differentiation calculus, conic sections, probability, permutation, everything again covered. 11th and 12th portion is covered in this particular schedule. So you can always replay back to this part and always check this schedule. These schedules might change by a day or two if needed, but most of the schedule will almost remain the same. So guys, for those of you who want to crack the JEE Mains examination, be it the second attempt, first attempt, third attempt, so this crash course is the last crash course before the next crash course begins again after a few more weeks. So again, things will get delayed because the crash course will keep on getting pushed. So the earlier the better it is, because then you'll have more time to prepare for advanced, because there will be advanced crash course also after some more days. So the entire syllabus coverage, just like I showed you. Also, there will be doubt solving in this crash course from morning till night, and these are live doubt solving and instantaneous doubt solving from our experts. And also you will have mock tests. There are in fact 20 mock tests planned for you. These are not previous year's questions, these are extra questions, most expected questions which are going to be in the mock test, and also they will be discussed after every mock test. Remember that. And also you will get all the notes which will be written on the board, including the slides, including the PDFs. Every PDF, whatever will be discussed in the class, you will be getting, and also you will be getting extra problems to solve after the class for homework in the form of sheets and revision. That is very important. And also you will have special tips and tricks session by our JEE experts, including Anand Sir, Pulkit Sir and other master teachers out there. So all of this is going to be combined in a very reasonable package of 10,000 rupees. But because of the Republic Day sale, we are giving you 30% off, which is a very good festival offer. Usually the offers are for 20%. So this is the last day of the sale. Tomorrow onwards we'll be back to 20% off, and the coupon code to get 30% off is SHCC21. The link for joining the crash course is there in the description box below, including the coupon code. Every detail of that crash course has been mentioned in the description box link. So please open it up on a separate tab and you can check it out later on. Very important thing, it is there in English medium. Remember, many crash courses around the country are not in English medium. So that's where, Vedantu comes in as, as a savior, because I know a lot of people face problems because of the Hindi medium classes as such. Okay, so the last batch is starting on 28th of Jan. Again, it will take some more time for a new batch, for the new attempt to start. So guys, do not miss this opportunity, is what I would like to say. Let's solve this question. There is some quantity of heat. There is some quantity of heat, come on, think about it, which can raise the temperature of X grams of a substance through T1 degree Celsius. So there is some quantity of heat which can raise the temperature of some object of X grams through T1 degree Celsius. And that can also raise the temperature of some other object of Y grams of water through T2 degree Celsius. Then what is the ratio of the specific heat of the object to the specific heat capacity of water? Come on, let's see how many of you get this. All right, come on, come on, come on, come on, come on, come on. Think about it. Think about it. Manoj, I will have to tell about this daily because every day there are new kind of people out here. Plus, every day there might be new people who would be interested in the crash course. So if you feel that you are not interested in that crash course, it's okay. You can close your ears, you can close your eyes and sit. Okay? So you don't have to feel forced about it. I'm not forcing it on you. You have to join the crash course. You have to join the crash course. No, it's an information which needs to be shared because a lot of students are interested in the crash course. I hope you understand that. All right. Cool. So, and I'm guessing Princey also made her point out there. So let's start solving this. Surely Manoj, I can repeat the entire rotation chapter, but that will be a waste of time, right? Hai? So wouldn't that be a waste of time? So understand, you can go ahead, watch the previous videos, it's there in the playlist. So please go ahead, watch in the playlist, entire rotation chapter has been covered, is there. Okay, chalo, let's start doing this problem. So guys, it's very simple. Here it is, the quantity of heat which can raise the temperature of X gram of substance. So heat required to raise the temperature of X gram of substance is same as the quantity of heat which it can raise for another substance of Y grams. Now what is the formula for Q? MC delta T. M is X, C I do not know, delta T is T1. For this object of X grams, the object's temperature changes by T1, specific heat capacity I do not know. For the Y object, the amount is Y grams, specific heat capacity I do not know, the temperature changes by T2. So you can see that I can immediately get C1 by C2 now. C1 by C2 will be YT2 divided by XT1, and that should be option number C, I believe. I hope this is clear. I hope this is clear. Yes, I hope this is clear. Cool. Let's get going to the next question coming up on your screen. How much heat is required to convert 10 gram of ice at minus 20 degrees Celsius to convert it into steam at 120 degrees Celsius? So you have ice at minus 20, you have to convert it into steam at 120 degrees Celsius. So everything what is required is given to you. Latent heat of fusion is 80, latent heat of vaporization is 540, and specific heat capacity for ice as well as steam is roughly 0.5, and specific heat capacity for water is 1 calorie per gram. Let's see how many of you can get this answer before I complete it. I'll be solving it slowly for all the minions out here because I will show you all the steps for getting to the final answer. But meanwhile, if you feel that you can solve this, please go ahead, no problem. Now think about the processes involved. So you have ice which is there at minus 20 degrees Celsius. First thing you need to do is convert it into ice at 0 degrees Celsius, correct? Then that ice has to melt, and once it melts it will become water at 0 degrees Celsius, isn't that right? And that water will be heated to again water at 100 degrees Celsius, isn't that right? And then that water will evaporate, it will vaporize, correct, into steam at 100 degrees Celsius. Remember, process of boiling or process of melting is isothermal, so that's why there is no temperature change while melting or while vaporization, and that steam will again convert it into steam but at 120 degrees Celsius. So these are the steps involved. Now think what will be the total heat. The total heat will be, first, from ice to ice. Think about it. Use the formula mc delta T. What is the mass? 10. What is C? 0.5. What is delta T? Delta T is 20. Correct? So from minus 20 to 0, it is plus 20 degree change. I hope this is clear. I hope this is clear. Next, think about it. Plus M into L. M into L, why? Because latent heat of transformation. So that will be nothing but 10 into latent heat of transformation. How much is this? Fusion, it is 80. So 10 into 80 plus this water converted into water at 100 degrees Celsius. So MC delta T. What is delta T? 100. C is 1. It's given. Specific heat capacity for water is 1. Plus more terms are there. Vaporization. So again transformation is there. So M into L. What is L? 540. So into 540 plus last term for steam MC, which is 0.5 into delta T. Delta T is 20. So these many terms will be there. Now solve this and check what answer you are getting. This should come out to be 7,400 calories, guys. This should come out to be 7,400 calories. Very good. I can see Vaishnavi out there and Shubdeep. Very good. 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 Ankit and so many other people. Very good. Excelente, guys. Excelente. Very good. I hope this is clear. Yes. Very good. Let's begin with the next question then. Cool. So the correct answer was 7,400 calories. This is how you do it stepwise. Now next point over here is about calorimeter. So what is a calorimeter? So calorimeter is a device used to measure different things about an object. Maybe to study the specific heat capacity, or maybe you know the specific heat capacity and you want to know the mass, or maybe you want to know the melting point, or maybe you want to know the boiling point, etc., etc. So it's basically used to analyze different thermodynamic aspects of an object. Now a calorimeter is usually completely made of insulating material. So there is wood, there is wool, there is thermocol, paper, etc. fillings outside, so that whatever is there inside that calorimeter cannot escape out, nor any heat can enter in. So if there is some hot water, some cold ice, etc., etc. in that calorimeter, you will see they will exchange heat amongst themselves and eventually they will settle down at a common temperature. That's when the thermal equilibrium will be achieved, and because you have placed a thermometer inside, you can see the temperature will keep changing for some time till thermal equilibrium is achieved, and you will see the temperature remains constant. So when the temperature becomes constant, that means the process of heat transfer has stopped. So remember, heat always flows. If this is a hot body and if this is a cold body, the heat flows. So this is nothing but heat flows from hot body to cold body until thermal equilibrium is achieved. So this is thermal equilibrium. Thermal equilibrium. And remember one thing, in the principle of calorimetry, the most important thing is the heat lost by hot bodies is exactly equal to the heat gained by cold bodies, because there is no other place for the heat to go. So whatever heat is lost by the hot body will be the heat which will be gained by the cold bodies till equilibrium, thermal equilibrium is achieved. This is the principle. Let's start solving problems based on this. Correct. So Rohit, it might not be T1 plus T2 by 2 always, because it depends on the mass and specific heat capacity. Imagine there is orange juice of some different mass and maybe mango juice of some different mass. So obviously it might not be always average temperature. So it depends. I hope this is clear. Okay. So let's begin with some problems. So you will see some really interesting problems out here now. When m1 grams of ice at minus 10 degrees Celsius, specific heat 0.5, it's given, is added to another mass m2 grams of water at 50 degrees Celsius, finally no ice is left and the water is at 0 degrees Celsius. The value of the latent heat of ice in calories per gram is how much? Let's start solving this problem. Let's first analyze what is exactly happening. So I'll just make some diagrams. You need not draw these diagrams exactly. This is just for your understanding. So imagine guys, you have ice. Okay, how many grams? M1 grams. At what temperature? Minus 10 degrees Celsius. Okay, and it is added with how many grams of water? Well, you have taken, right? You have taken how many grams of water? Let's see. You have taken M2 grams of water, and at how much temperature? 50 degrees Celsius. Now, obviously what will happen? The heat will go from the water to the ice. It will try to melt it. But first, the ice temperature must go till 0 to first of all melt it. And it is given in the question that finally no ice is left and the water finally is at 0 degrees Celsius. That means what happens? This water will give away that heat to melt this ice. So this ice melts into water. Okay, this ice melts into water. This water cools down. Okay, this water cools down. And finally, what do you have? You have a mixture of water which is both at 0 degrees Celsius. This is M1 grams, this is M2 grams. Think about it. This has cooled, this has heated up. So ice heated up and melted, and that's why you have water at 0 degrees Celsius. Now once both their temperatures are 0, they cannot exchange heat. Understand that. That is the problem. I hope this is clear. Ankit, I hope now you have understood it. I hope now you have understood it. Acha Rohit, I did not read that identical bodies. My bad. Okay, if identical bodies, yes Rohit, whatever you said is correct. Okay, I hope this is clear. Cool. So Ankit, which part you did not understand? See, I'll tell you again. There is ice. Okay, it's at a very low temperature. This will acquire heat from that hot water which is at 50. Once it acquires heat, the temperature will slowly increase, correct? The water's temperature will slowly come down. Eventually, nothing is remaining in ice form, everything is in water form. And it's a mixture of water at 0 degrees Celsius. So what does it mean? That the ice had enough heat from this hot water to raise its temperature to 0 and also melt itself and convert it into water. That's what it means. And finally, what you have is a mixture of water from this hot water as well as the melted ice. That's what it is. I hope this is clear. I hope this is clear. Yes. Okay, cool. Now, who is losing heat? So think about it. So heat lost by hot water. So heat lost by hot water is equal to, because the hot water has lost heat, is equal to heat gained to, first of all, increase the temperature of ice and then to melt it. Remember, so heat is required to not only increase the temperature of ice but also to melt it. So there will be two terms over here. Keep this in mind. So how much is the heat lost by the hot water? mc delta T. What is the mass? M2. What is the specific heat capacity of water? Is that given to me? Well, in fact, well, it's not given, but I think we should assume it as 1 because that's a standard value, into how much is the delta T? Delta T is 50. Now, some of you might say, sir, should I put minus over here? No, because already I have used the word lost. Because I have used the word lost, so there is no need of minus. Okay, it's just like give and take. I gave you 100 rupees. You got 100 rupees. I gave 100, you got 100. So 100, 100, both should be there on LHS as well as RHS. I hope this is clear. So guys, now, yeah. So over here, the heat gained will be for two reasons. To increase the temperature of ice. So mass of ice is m1, specific heat capacity is 0.5, delta T is 10 because from minus 10 to 0, plus to melt it you will require m1 into latent heat. Latent heat is something which I have to find out. So this will become 5m1 plus m1 into L, and over here it will become 50 m2. Now take this term over here, so you will get 50 m2 minus 5 m1 is equal to m1L. Now shift m1 below, so you will get latent heat as 50 m2 by m1 minus 5. Now that should be the final answer. I hope this is clear. I hope this is clear. Everybody understanding this? No, Abdul, it should not be negative. That is wrong. If somebody has told you it should be negative, that is wrong. Abdul, understand, mere bachche. See, if it was written like this, object 1 plus object 2 plus object 3 is equal to 0, then you will have to worry about that plus and minus sign. Somebody will increase the temperature, somebody will decrease the temperature, somebody will increase the temperature, net change will be 0. That's when you will use the signs. But over here we don't have to put plus or minus, because I'm asking how much is the heat lost by water. Heat lost by water will be mc delta T. The delta T should be positive. I hope this is clear. Yes. Okay, I will give you another example, Abdul and others. Think about it this way. If I give you 100 rupees, okay, if I give you 100 rupees, then you will get 100 rupees. So I have lost 100, you have gained 100. So on the LHS, if there is a positive number, on the RHS also there should be a positive number. So how much is the money I lost? 100. You won't say I lost minus 100, because if I lost minus 100, that means I have gained plus 100. I hope that makes sense. Is that clear? I hope, Ankit, now you have understood it. Yes, yes. I hope this is clear. Cool. Okay? Let's do one more good problem. I know a lot of people ignore calorimeter, but trust me, calorimeter is the chapter which is going to fetch you marks in the final examination. No, Finnegan, in chemistry it is not opposite. Who said like that? It is the same in physics and chemistry. Sign conventions for heat does not change. Like I just said before, if you wanted to do it like, you know, object 1 plus object 2 is equal to 0, then you will worry about the sign. mc delta T plus mc delta T2, okay, is equal to 0. Over here, you will have to worry about the signs. Oh, this is final minus initial, because one person might increase the heat, one person might lose the heat. So net change will be 0. But when you shift one guy on the other side, understand that minus sign has already been taken into account. So, you know, you're just talking about the mod values. Their mod values should be equal. That's what I'm trying to equate. I'm forgetting that minus sign. I hope this is clear. Okay? So, it might be in different sense, Finnegan. It might be in different sense. Okay? So, do not worry. Over here, what we just did, we solved it via this method. The heat lost is heat gained. So, when I say lost, okay, fine. I have just put a modulus and equal to the heat gain, I have equated the both. But if you're writing it in this form, then you can write it in plus and minus. I hope this is clear. Cool. Let's get going to the next question. M grams of steam at 100 degrees Celsius is mixed with 200 grams of ice at its melting point in an insulating container. That means a calorimeter. Okay. If it produces liquid water at 40 degrees Celsius, heat of vaporization is given, heat of fusion is also given. What is the value of M? So first let's visualize this, guys. Let's try and visualize this. M grams of steam. Okay. So you have steam. Okay. This is steam. And how many grams? M grams. At what temperature? 100 degrees Celsius. And you are mixing it with 200 grams of ice. Okay. So this is basically ice of 200 grams and it is at its melting point. That means at 0 degrees Celsius. What do you think will happen? Now anything can happen. The ice may melt, the steam may condense, and maybe, you know, there might not be enough heat to melt the ice, or maybe there might not be enough ice to condense the steam, or maybe they are just enough and maybe they form water, and again this water which will be formed from ice will be colder this water which will be from the steam will be hotter, and again they will exchange heat and they will form a mixture. Isn't that? I hope this is clear. I hope this is clear. Now understand what will happen next. It is given in the question that it produces liquid water at 40 degrees Celsius. So both of them, they exchange heat and they eventually just become water. They become water eventually at what temperature? 40 degrees Celsius. I hope this is clear. So now somebody has lost heat. Who has lost heat? Steam has lost heat. Who has gained heat? Think about it. When ice converts into water, obviously it will gain heat. Amount of energy lost by steam will be the amount of energy gained by ice. I hope this is clear. Now, if you have understood till here, let's try and solve this problem. So, I will say heat gained to melt ice and increase water temperature. Why increase the water temperature? Because when the ice melts, first thing it will be water at 0 Celsius. You have to make that 0 Celsius water to 40 Celsius water. So heat required to melt the ice and increase the water temperature should be equal to the heat lost to condense the steam. Now when you condense the steam, it will become water at 100. So again you have to cool it further and cool it till 40 degrees Celsius. Correct? Now think about it. What is the heat gained by to melt the ice? Well, how much grams of ice is there? 200 grams. So 200 into, to melt it, you will need 80 calories per gram. So for 200 grams, 200 into 50. Plus, to increase the water temperature. So once you melt it, you have 200 grams of water. So C is 1, delta T 40. Understand? Because from 0, you are bringing it to 40 degrees Celsius. I hope this is clear. I hope this is clear. Now, how much is the heat lost by condensation? Oh, the steam mass is m. So heat loss will be m into 540 is latent heat for condensation vaporization. So m into 540. I hope you understand why I have not put a minus sign. This is give and take relationship. I hope this is clear. Plus m, c and delta T, please do not put it as minus 60, it is 60 only. Because this is heat lost. So, I'm putting it as, m into 1 into delta T, which is 60. Now you just need to solve this. 2 into 5, 10. Okay, so just check this out. I hope this is clear. Oh, 1 second. This was not 50. This was 80. My bad. I don't know why I wrote 50. This was 80 calories per gram. So this was supposed to be 80. Okay, cool. Now, 2 8s are 16. So 16 is 1, 2, 3 zeros. And over here, 2 4s are 8. And 1, 2, 3 zeros. So this will become 60 plus 540, which is 600 m. Now 16,000 plus 8,000 is 24,000. 24,000 divided by 600 will become 40. So this will become 40 grams. I hope this is clear. No, it is 40 grams. Just check this out. Ankit, which formula are you talking about? Are you talking about which formula? You mean to say this formula? I just did. I don't know whether you are there at the start of the session. I just wrote Q is MC delta T and also Q is ML. So I'm just using these terms as and when needed. Somewhere I'm using ML, somewhere I'm using MC delta T, wherever heat is lost or gained. That's all. No, Sridhar, waves is not completed. I'll be completing it in the next few weeks. Don't worry. Okay, cool. Let's get going to the next question now. Now, yes, 40 grams is the answer. Guys, are you now a little bit confident about calorimeter and heat exchange? Are you able to understand how these things are done? Yes, very good. No problem, Aishwarya. So Dhanush, see, if you have problem when to use latent heat, see, whenever there is phase change, use latent heat. Remember that one problem which I did just now, sometime back? Where did it go? This one. This is the most important problem. Very important problem. This tells you when to use latent heat, when to use MC delta T. So if you miss this problem, I would request you to please rewind back to this part and see how I did. I explained it neatly how to use which formula, when to use which formula. So just do that. Okay. Very good, Yalini. All right. Okay. Dhanush, is that fine? Cool. Let's get going to the next part of this lecture. Now, Saurabh, I might not be able to take a lecture for semiconductor for KVPY, but I will definitely take it before your JEE Mains. Don't worry. Okay? Like I said, I don't want to force everything in one shot. Okay? We will do everything properly. Our eventual aim, Saurabh, is JEE. Remember, yes, KVPY is also our aim, but whatever we do, we are doing it properly if you understand that. You know what I'm saying. Now, Sashita, all the PDFs are provided. It's there in the description box or in the Telegram group. Now, in kinetic theory of gases, the most important thing you should first do is go open up NCERT or HC Verma and read all the important assumptions out there. Very important assumptions are there, like the molecules of the gas are moving randomly. The molecules of the gas, when they hit the walls of the container, that creates the notion of pressure, and the molecules are distributed randomly everywhere. The speeds of the molecules are different. The size of the molecule is very small as compared to the size of the container, and there is equal probability of a molecule going there or here. And all these kind of things are there. The collisions are elastic, etc., etc. Some of them have been mentioned here. It will be obviously available to you even in the PDF. But for now, I'm telling you, please read through it through in NCERT or in HC Verma. Okay? So that's something which you need to do. Cool. So let's get going and see some important formulas. See guys, like you saw in this simulation out here, these are the molecules of a gas. Now, if you observe carefully, not all the molecules have the same speed. Some molecules are very energetic, some molecules are low on energy, some molecules have decent energy, and you will see there are very few molecules with very low energy and very few molecules with very high energy. Most of the molecules have a decent amount of energy and they keep exchanging their energies during the collisions with the walls or with each other. So there is a very important graph. There is a very important graph which you should know. Yes. And that is this one, the Boltzmann curve. And this curve is valid even in your normal life. Like if I tell you in your classroom, right? If I tell you, arrange the students height wise. So this is the number of students. This is the number of students and this is the height. You will see the graph will be something like this. Maybe at some height, I don't know, maybe 5 feet, 5 inches. Most of the students are here. Very few students at 6 feet. Very few students at 5 feet or below it. Something like that. Also, this can be valid even for the marks. If I tell you marks of the students. So this is number of students. This is marks of the student. Okay? So the graph will again be like this. Very high marks, very few people will have. Very low marks or failures will be very less. Most of the people will be in this range. Isn't that true? So this is how the graph is. This is called as a normal curve, normal distribution curve. Now, let's say for example at room temperature, forget the violet or the red graph. You will see these are the speeds of the molecules. These are the number of molecules. You will see most of the molecules have a particular speed. Very few molecules have very high speed. Very few molecules have very low speed. But if you increase the temperature, that is if you go from room temperature, if you make it into a hotter gas, then this curve will shift. You will see the molecules which had a particular speed, they will shift to a higher speed because they have now become hotter. And if you make the gas colder, then this is very, very clear. Yes, I hope this is clear. So Ankit, there is a separate chapter called as Calorimeter. You can find the questions there. And if you still have some more doubts, please ping me on Instagram or write a comment after the video or the lecture. I'll definitely help you out. Okay. So now, if you understood this, let's talk about the three important speeds of the molecules of a gas. The first one is called as the most probable speed. Okay guys, the most probable speed. That is the speed which most of the molecules will have. And that formula, I'm pretty sure you would have seen it in chemistry, but still I'll give it to you over here. Okay, very important formula. It is 2RT by M. What is R? R is your normal gas constant. What is T? Temperature in Kelvin. What is M? Molecular weight. So this is the molecular weight. Okay? Make sure you express it in kg per mole. Okay, this is your temperature in Kelvin. Be careful, not in degree Celsius, or else some might say at 0 degree Celsius the speeds are 0. No, it's always in Kelvin. And R is your gas constant. Everybody knows the value. So this is one formula which everybody should know. Most probable velocity. Next is average speed. Now the average speed of a molecule is nothing but V1 plus V2 plus, there will be n number of molecules, the whole thing divided by n. So you just take the average of all the speeds. That formula you should remember, it comes out as 8RT divided by pi m. So that's the average speed. It's slightly higher than the most probable speed. Remember that. Remember that. Thank you, Jyoti Basu. Thank you so much. Okay, I hope this is very, very clear. Now, if this is understood, let's get going. Okay, I hope you have written this down in all your notes. Remember, average speed is slightly higher than the most probable speed. Next up is the RMS speed, root mean square. Like this name suggests, root mean square. The root mean square speed suggests VRMS is the root of the average of the squares. That is V1 square plus V2 square plus Vn square, the whole thing divided by n. So it's the average of the square is the root. So that is VRMS, and this VRMS value comes out to be 3RT divided by m. So this is again another important formula which you must know. 3RT by m, it's higher than average as well as most probable. This is where it comes on the graph. Keep it clear. Okay, so Dinesh, what is the difference between most probable? Like you can see graphically, the most probable speed is that speed which most of the molecules have, but it need not be average. You can take some random values 1, 5, 7, 10, etc. You will see that value which is most occurring is most probable, but average is actual mean or the average value of all the speeds. RMS is the average of the squares of the molecule. I hope that is clear. Yes, I hope this is clear. Cool, let's get going. Here is the next question. In the thermal equilibrium, the average velocity of gas molecules is, which of the following option is correct? Come on guys, let me know. Come on, think about it. Which of the following option is clear? In thermal equilibrium, the average velocity of gas molecules is proportional to root T, proportional to T square, proportional to T cube, or 0. Okay, most of you are saying A, some of you are saying D as well. Well, let me tell you, the correct answer is D. Why? Read this word very carefully. Average velocity. Very important. It was not average speed. Velocity. One molecule's velocity will be here, others will be here, others will be here, others will be here. If you take the average velocity bar, which is V1 bar plus V2 bar plus Vn bar by n, this will be 0. But if you take, V1 plus V2 as a ... by n, this will be not 0. That is proportional to root T. Be careful. That is why it is a very tricky question. Yes, Ankit, you are correct. Yes, 0. Yes, Uttam, very good. Uttam, you said C, I believe, initially. Yes, Brajesh, I know you are in my regular batch, but you can often come here and stay in touch. All right, so let's get going to the next question. At a certain temperature, the RMS velocity of oxygen, RMS, is 400 meters per second. At the same temperature, what is the RMS velocity of hydrogen molecules? Come on, think about it. Think about it. Well, Anand, what can I say? Actually, if you are taking speed as velocity, that is slightly wrong, but don't worry, in the final examination, the examiner or the question paper setter will take care of all these terms, because he knows that a person writing chemistry also has studied physics. So don't worry. All right, so let's see how to solve this question. So what is the formula for RMS? The formula for RMS is root of 3RT by M. Now 3 is a constant, R is a constant, temperature is same, it's given in the question, so it is inversely related to the root of M. So velocity for hydrogen upon velocity for oxygen is nothing but molecular weight for oxygen upon molecular weight for hydrogen, okay, under the root. Now what is the molecular weight of hydrogen, oxygen, sorry, it is 32, okay, oxygen, which is O2, and for hydrogen it is nothing but 2, and this is nothing but VH2. Oxygen is nothing but given to be having a speed of 400, so I'll just put 400 over here. So VH2 will be 400 multiplied by 32 by 2 is 16, root of that is 4, so that will give you 400 into 4 is 1600 meters per second. That is option number C. That's the correct answer. Very good. Many of you got it. Excellent. Very good. Very good. Let's see how many of you get the next question. The respective speeds of the molecules of a gas are 1, 2, 3, 4, 5 kilometers per second. The ratio of their RMS and average velocity. Actually, this should have been average speed, guys. My bad. So read this as average speed. Okay? Because average velocity will be 0. Come on. What will be the ratio of the average, RMS and the average speed? Come on. Let's see how many of you get this. Let's see how many of you get this. Okay. Chalo, let's start solving this question. First of all, let's find the RMS value. The RMS value is root of 1 square plus 2 square plus 3 square plus 4 square plus 5 square divided by 5. How much will this be? Think about it. How much will this be? Come on, think about it. How much will this be? 1 square, 2 square, 3 square, 4 square, 5 square. Come on, add it up, divided by 5. How much is it? How much is it? Think about it. Isn't it root of, this will be 55 divided by 5 will be root of 11. And what will be the average speed? The average speed will be 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So this will be how much? Come on, come on, come on, come on, come on, come on. Think, think, think. How much are you getting? 5 plus 4, 9, 9 plus 3, 12, 12 plus 3, 15, 15 by 5, 3. So the ratio will be root 11 by 3. That is the correct answer. Very good. No problem. Happens. Preetanand, do not spam out here. Do not spam out here, or else you will be blocked. Yes. Chalo, let's get going to the next question. But before that, gas laws. Very important stuff out here. Very important things. You would have studied this in chemistry. A quick recap. Remember, gas law for ideal gas is PV is nRT, where n, small n, is the number of moles, and this R is nothing but 8.3, right, joules per mole per Kelvin, or you can write it approximately as 2 calories per mole per Kelvin, or 0.082 liter ATM per mole per Kelvin. All these things you know. Okay, you can also write this in a different form, and that is PM is equal to rho RT. This is also an alternative form for gas law, where what is M? M is molecular weight. Molecular weight of that gas. And what is rho? It is nothing but the density of that gas. So sometimes you might need to get it in forms of density. Also some other terms which you should know. Small n, which is nothing but the number of moles, is total molecules upon Avogadro number. This is your Avogadro number, 6.02 into 10 to the power 23. This is capital N, not small n. This is number of molecules. Remember that. This is another important thing you should know. And last thing over here, the molecular weight divided by Avogadro number. So molecular weight divided by Avogadro number gives you small m. This small m is the mass of a molecule. Very, very important. A single molecule. So this is the molecular weight per mole. So for 6.02 into 10 to the power 23. But if you divide it by the Avogadro number, you will get it per molecule. That is very important. I hope this is clear. Yes, this is very, very important. Is that understood? Is that understood? I hope you have written down all these important formulas based on gas laws. Yes, let's get going. Now, equations for kinetic theory of gases, which are very, very important for you. This is one of the most important equation. PV is equal to 1/3 N. Okay, 1/3 N M V RMS square. This is very, very important formula. You should know this. Please note that this M stands for number of molecules. Like I said before, capital N, it's not small m, and this small m is mass of a molecule. Very important formula. You should know this. Most important equation of KTG. PV is 1/3 NMV square. Okay, 1/3 NMV square. Very, very important. Cool. Let's get going. Is gas law questions asked in chemistry only or in physics? Dhanush, it can be asked in physics also. Yes, there are questions in physics also. Okay, let's see how many of you get this. The pressure of a gas does not depend on. Let's see how many of you get this. Very good, Jay. Come on, think about it. The pressure of a gas does not depend on kinetic energy of the molecules, speed of the molecules, density of the gas, the volume of the gas when the density remains unchanged. Which of the following? Come on, think about it. C, D. All right. So here is the answer, guys. The correct answer. Kinetic energy of the molecules, yes. Speeds, yes. Density, yes. Volume of the gas when the density remains unchanged. So you have to use your gas equations. That's it. The volume of the gas when the density remains unchanged. So just use Pm is equal to rho RT. Guys, pressure, if for a given gas M is constant, density remains unchanged. Matlab density is constant, R and T, everything is constant. So obviously it will not depend on the volume. You can see that over here. So that is the correct answer. Okay, so option D. Let's get going to the next question. All right. So two gases having pressure P, volume V, temperature T are mixed. Two gases having same pressure P, volume V and temperature are mixed. The mixture has a volume and temperature V and 2T. What is the final pressure of the mixture? Very simple problem, but important problem. You should know it. So you have a gas A and you have another gas B. What is the pressure P? What is the volume V? What is the temperature T? Okay. Now when you mix it, okay, that mixture A plus B, what does it have? Pressure I don't know. Let's say I call it P1. Volume is V and temperature is 2T. Now from here to here, what is constant? Moles of the gas is constant. That's what you should keep in mind. So the concept that you should be using is mole conservation. So by mole conservation, N1 plus N2 will be equal to in that final mixture, whatever total number of moles are there. So what is N1 plus N2? Think about it. N1 will be, because PV is equal to nRT, N will be PV by RT. So PV by RT plus PV for the second gas by RT for the second gas is equal to total, the mixture, the pressure is P1, volume is V, and temperature is 2T. That's it. So this will first of all cancel out R, cancel out V, and cancel out T. So you'll get 1 plus 1 is equal to P1 by, P plus P, my bad, P is there, P plus P is equal to P1 by 2. Now P plus P is 2, 2 2s are 4, so 4P is equal to P1. That is the answer. So the pressure would have become 4 times. Yes, looks like many of you did not get it. No problem, no problem, no problem. Happens. All right. Okay? So this is the correct answer, and this is how it has to be solved. Some of you overestimated yourself and some of you thought this was very easy. So guys, you should know these kind of problems when mixture is there. So it's just the moles which are conserved. Okay, let's get going to the next question. Very good. Now, degrees of freedom. Very important, and we are coming towards the end of the lecture. So stay tuned guys, and I hope you have already liked the video, and if you're a new user, I hope you have subscribed to this channel. Come on guys, if you have not done it already, please do that. All right. Now here is the thing. What is this degree of freedom? So it's the independent, motions that a molecule can have which can contain energy. For example, say, I have a sphere. Okay, just imagine I have a sphere. So I don't have a sphere right now, but just imagine I have a sphere, and that sphere can move like this, can move like this, can move like this, can move like this, can move like that, can move like that. It can also spin like this, and also like this. It can spin. So there are 1, 2, 3 degrees of freedom. Apart from that, 1, 2, and 3 degrees of rotational freedom. But understand, those degrees of freedom which do not have significant contribution towards energy should not be accounted for. So if I take a monoatomic gas, very important, then understand it can translate in X, Y, Z. It can also rotate, but that rotation is insignificant because that monoatomic molecule is like a point mass. So the rotational kinetic energy of a point mass is negligible. So that's why I only say there are 3 degrees of translational freedom. I hope this is clear. Thank you guys for reminding me. Yes, so 3 degrees of freedom, but if I tell you one more important thing, there's one more important thing, and that is law of equipartition. These are all chemistry concepts, but I'm telling you here just like revision. Law of equipartition of energy. It says that the energy per molecule per degree of freedom is half kT. Now what is this K? This is called as Boltzmann constant. You might have already heard about it, and it is R divided by Avogadro's number. So the energy per molecule per degree of freedom is half kT, and each degree of freedom has equal share of energy. Now since there are 3 degrees of freedom, one in X, one in Y, and one in Z, so the energy of this molecule, because there are 3, so it will be 3 into half kT. That's the answer. 3 into half kT. I hope this is clear. Yes, yes, I hope this is clear. Okay, so remember this law of equipartition of energy. Energy per molecule per degree of freedom is half kT. Okay, now next up, for diatomic, 3 translational, 2 rotational. Why not 3 rotational? Because see, imagine a dumbbell. If it rotates like this, then 2 heavy masses are going around each other like this, so it has some significant contribution of energy. Also, those 2 masses going like this have significant contribution of energy. But those 2 masses rotating like this, it's like 2 point masses spinning about their axis. Those are point masses, so they will have negligible contribution. That's why 3 translational and only 2 rotational degrees of freedom. So in all, totally you have 5 degrees of freedom. So the energy of a diatomic molecule, will be 5 times of half kT. Remember that. Half kT is per degree of freedom. Totally it is 5. So 5 into half kT. Remember that. I hope this is clear. Yes. Now, those 2 masses rotating diagonally, Kirito, they can have components. So we have resolved it into components in X, Y, Z for simplicity. That's why. So the diagonal will have 2 components. Think of it that way. Hello, Samir. Next, triatomic linear also, again 3 translational, 2 rotational, same like diatomic molecule. Okay, same like diatomic molecule, so totally 5 degrees of freedom. And lastly, if it is a triatomic non-linear molecule like H2O, this example is H2O, for this the example is carbon dioxide. Carbon dioxide molecule is a linear molecule, triatomic. So for a triatomic non-linear, 3 rotational and 3 translational. So guys, think about it. What will be the total degrees of freedom? The total degrees of freedom will be 6. So the energy of a non-linear triatomic molecule will be 6 into half kT, which will be 3 kT. Remember that. K is Boltzmann constant, T is temperature in Kelvin. Keep this in mind. Now this table, you should remember it. In fact, I had given it to you on Monday also. So monoatomic, diatomic, non-linear, polyatomic, etc. This is internal energy of the gas. This is CV of the gas. This is CP of the gas. This is gamma, which is the ratio of CP by CV, and gamma's formula is 1 plus 2 by F. So if you know the degrees of freedom, let's say 3, so 1 plus 2 by 3, which will be 3 plus 2, which is 5 by 3, will be 1.67. So CP, CV values for everything you should know. Keep this in mind. Keep this in mind. Hello, Phantom Garages, welcome. All right. Cool. Let's get going to some problems then. Yes, let's solve some problems. The mean kinetic energy. If you want, take a screenshot, guys. If you want, take a screenshot of this if you need it. Okay, you can take a screenshot of this. Don't worry, all of this will be available in the notes as well. Okay, so mean kinetic energy or average kinetic energy of 1 mole of monoatomic gas is given by. How much will be the average kinetic energy of 1 mole of a monoatomic gas? So the energy of 1 mole, right? 1 mole monoatomic gas. Think about it. How many molecules are there in 1 mole? There are Avogadro number of molecules, correct? Na number of molecules into energy of a molecule. So if I take a molecule's energy and multiply by Avogadro number, I'll get the total energy of 1 mole. Okay, great. Now what is the energy of 1 molecule? Well, it is a monoatomic gas. It is clearly mentioned. So monoatomic has 3 degrees of freedom, and each degree of freedom has half kT of energy. Great. But think about it. What is the value of K? It is R by Na. Correct? So it will become 3, or if you want, just put Na over here, into 3 into half K is R by Na, and into T, Na goes. Cancels. What is remaining? 3 by 2 RT. Remember this. That's it. Very simple. In fact, this will be also CV into T. This will be also CV into T. CV for that gas is 3/2R. Correct. Yes. So that is the answer, guys. Option A. Let's get going to the next question. Yes. Next question. Small n moles of a diatomic gas in a cylinder are at some temperature T. Heat is supplied and the temperature of the gas remains constant. But then you will be wondering, what did that heat do if it did not change the temperature? It has split the diatomic gas and converted it into a monoatomic gas. What is the change in the total kinetic energy of the gas? Let's see. How do we do this? So a diatomic gas absorbed heat and split into monoatomic gas. Let's see how do we do this. So first of all, let's visualize this. So you have a diatomic molecule, n number of moles are there, and what happens? You get 2n moles of monoatomic gas, isn't it? So just think about it. What will be the energy of these many moles of monoatomic gas? Well, for that, let's think, what do we do? What is the change in the kinetic energy of the gas? Now, what is the formula for the internal energy of a gas? The formula is, remember, the internal energy of a gas formula is NCVT. Change in internal energy is NCV delta T. So just internal energy is NCVT, nothing else. So use that. There are 2 moles of monoatomic, so 2N. CV for monoatomic is 3R/2, okay, and temperature is just T. For a diatomic, there is only N moles. CV is 5R/2 and temperature is just T. So just take the difference, guys, of both of them. Just take the difference and find the modulus, whichever is higher. So this will become just 3, and I hope this is clear. And this is just 5/2, or you can just say it is 6 minus 5, which is just going to be half nRT. That's what I'm going to get, I guess. Yes, option A should be correct. Very good. Very good. This should be correct, and many of you have got it. Is that clear? Shall we go ahead? Half nRT. Last point of today's chapter. Last point, and that is mean free path. Remember, I just showed you the motion of the molecules, how they go zigzag randomly here and there. So think about it, guys. If the molecules are going zigzag, let's say I concentrate my focus or attention on one molecule, it goes like this, hits another molecule, again hits another molecule. Between every collision, it is traveling some distance, correct? These distances are not same. These distances could be different. So the average of all these distances is called as the mean free path. Sometimes it might hit quickly, sometimes it might hit late. So the average of these distances, the total distance upon total collisions, is called as the mean free path. And there is a formula for that, and lambda average, this is the mean free path, is given by, not sure if you know this formula, it is V divided by root 2 pi d square into n. This is that formula which you must know. Now you might be wondering what each term is. V is volume, obviously. What is n? It is number of molecules. It is the total number of molecules. What is this d? Be careful. This is the diameter. This is the diameter of a molecule. Very important. This is the diameter of a molecule. You should know this formula. Kavya, I will be taking wave optics in a week or two. Don't worry. I'll be completing all the syllabus. So some of you are asking about waves, some of you are asking about, sound, etc. Semiconductors, everything I'm going to do. Don't worry. Have faith in me. That's all. Okay? Cool. Now, last question for today. If the pressure in a closed vessel is reduced by drawing out some gas, what will happen to the mean free paths? Ankit, yes. You should do all the objective and the short answer and the solved questions. but exercise wise you should do at least 50%, not necessarily 100%. Come on, think about it. What should be the correct answer? If the pressure in a closed vessel is reduced by taking away some gas, what will happen to the mean free path? Will it increase, decrease, remain same, or depends on the nature of the gas? Come on, think. Well, some of you are saying B, some of you are saying A, most of you are saying B, some of you are saying C also. Well, guys, think, when you reduce the pressure, what will happen to the volume? Volume will, think about it, if you reduce the pressure, what will happen to the volume? It will increase. And where was the volume? On the top. Remember that formula for lambda, average mean free path, V divided by root 2 pi d square n. So V was on the top. That means if volume increases, the mean free path will also increase. That's the answer. Correct. Now, I've kept 3 questions, objective ones, to try it out at home. So do check them out. Which of the following temperature would the molecules of a gas have twice the kinetic energy at 20 degrees Celsius? This is your first question. This is your second question. 3 grams of liquid is mixed with 1 gram of another liquid. What is the final temperature? Sorry, the final temperature is given. Find the specific heat. And the third question, at what temperature the RMS speed of nitrogen equals the oxygen molecule's RMS speed at 47 degrees Celsius. All the answers and the solutions will be posted on the Telegram group. The link is in the description box below. So please check it out. This is our official group for all the announcements. And please remember, today is the last day for your enrollment in the crash course, where you are going to get the most amazing faculties. Yes, the top-notch faculties. And you know, this batch is going to be in English. That's one thing to bear in mind. And also, you don't have to travel anywhere, so no distractions, of course. And obviously, if you can check our previous year's results, you will be definitely thrilled to know 500 plus students cracked JEE Mains advanced exam. More than 500 cracked JEE Advanced, many more cracked JEE Mains. So guys, you should definitely join a reputed institute, and you know, you'll be getting revision material, handwritten notes, quizzes, as well as assignments. So all of this with doubt solving, also complete 11th and 12th syllabus coverage, and also there will be test series, 20 of them with discussions, and very important strategy sessions by our very famous master teachers and Pulkit sir and Anand sir as well. So remember, this is a Republic Day sale, and usually there is 20% off, but because of the sale, last day today, 30% off, and you will get the course which is usually at 10,000 at 7,000 rupees. Remember, the course starts tomorrow. So if you are a 12th or a dropper student, this course is exactly for you, so that you can boost your performance for the upcoming JEE Mains examination. Very, very important. All right. So guys, that's it for today. I hope you have loved the video. I hope you have subscribed to our channel, and I'm pretty sure you're going to spread the joy of learning with other people out here. So take care, guys. Bye bye. Have a great time. See you tomorrow for the mock discussion paper of JEE Mains 2020. All right. Be there at 7 o'clock sharp. Take care. Stay at home and be safe.